Hello and welcome everyone. Very happy that we're all together again. In this tutorial, we will continue talking about our important concept in the GD&T world, which is the datum. So fasten your belt and let's get started. The aim of this tutorial is to understand what the datum is in general, so we need to discuss the datum. Also, we will compare between the different types of datums. And finally, we will understand what the datum priority is. So let's go ahead. First of all, if we need to understand what the datum is, we can say that it's the reference surface or the starting point or line that we take as a reference to detect the location or the orientation of any feature. So the main idea behind the datum is that we need a reference or a standard object that we can relate all of the other objects to. So it has the same idea of the ruler zero level. As for the ruler, if we need to measure any length, we set it from the zero level of the ruler. So for the ruler, we consider this zero level to be the standard point that all of the other points are measured with respect to. And the same idea here is applied to the datum, as if we need to specify the positional tolerance of this shaft on this plate. As we learned before, the translation of this tolerance annotation will be that the center of this shaft is having a tolerance of a value of 0.2, and this is related to the datum P. So the datum here works as a reference or as a zero level in the ruler example to specify the tolerance of the whole center according to it. Hence, we specify the ideal position of the whole center related to the datum feature P to P5, for example. And this means that the whole center is having a tolerance of 0.2, and this is related to its ideal position or its theoretical position. So that's the basic idea behind the datums. That is very important as it's related to the tolerancing operation directly. So we cannot make most of the tolerancing operations without specifying the reference datum. Alright. Now the datums have some important different types that we may face frequently in the geometric dimensioning and tolerancing world. So let's explore them now. Here, the first type of datums we have is called the single datum feature, and this is the simplest type of datums, as at this type of datums we have only one reference or one datum, like the previous case that we have just discussed. Here we need to specify the tolerance of the whole center related to one datum only, which is this surface feature P only. Also, the second case of the datum feature is to have two or more than two features, but they have the same priority. And an example of this, if we have this workpiece, for example, and we have two datum features, datum A and datum P, as you see. But the two datum features are specified according to the same axis or the same reference line. As you see, they are aligned on the same level or the same reference line, and for this reason we say that those two features are having the same priority, as the priority here means that we can start the tolerancing operation from any datum of them, as both of them are on the same level. And for this type of datums, we refer it by this annotation here. Here we type the features we have and we separate between them by the hyphen sample, as you see. So if we have two datum features or three or four datum features, for example, we will type them on the same digit, but we separate between them by the hyphen sample. And this is to express the datum features with the same priority. Also, we have another datum case, which is to have two or more than two features with different priorities. but this priority is not specified, so the tolerance annotation doesn't specify which datum feature is having the highest priority. And at this condition, the datum features are typed beside each other with no split between them, so they are typed directly besides each other. But this is not the good tolerancing expression, or it's not a good way to describe the tolerance annotation, because it doesn't specify which datum feature has the highest priority or which one has the lowest priority. So there will be an unknown piece of information, which is the priority arrangement, and this leads us directly to some errors in the measurements of the workpiece, because if we considered the workpiece to have datum A as the primary feature, we will have some results of measuring the workpiece, and if we considered the datum feature P to be the primary datum, we will have some different results of the measurement of the workpiece with respect to the first one, or compared to the first scenario. So we don't recommend to use this method of expressing the tolerancing operation. And for this reason, we recommend to use the next tolerancing method, which is to use two or more than two datum features, and each of them has a different specified priority, which means we know this is the primary priority feature and which one is the secondary priority feature, and so on. So the primary priority feature is this one that is written firstly, and the second priority feature is the second one that is written secondly, and the tertiary priority feature is the third one that is written thirdly. And we state each of them in a separate part, or we state each of them in a separate digit. And we can take an example to understand that priority technique. Suppose we have this mechanical part, so this is its shape as a 3D model, and this is its elevation plan here, then this is its side view plan as you see. Now we have three datums of this isometric, but with different priorities. The first one is the datum feature A, which is the primary datum. Then we have the datum feature P, which is this line profile feature. After that, we have the datum C, which is this line profile feature. So those are the three datums with their different priorities. But you may ask now, what's the benefit from arranging the datums into some different priorities? So this is the question what we will answer later, and that's about this tutorial. More than great. Hope that's clear right now. Thank you for watching and see you next tutorials.